guys, Mrs. Ard back with you with our next lesson. This lesson is called Multiply with 9. We have learned our zeros, our ones, our twos, threes, fours, fives, sixes, sevens, eights, and tens even. And now we're going to learn our nines. This is exciting. We will have gone through every number 0 through 10. Are you ready? This is the last one. You guys are so smart, and I'm so proud of the hard work that you've put in recently learning your multiplication facts. So let's look at our essential question. What strategies can you use to multiply with 9? Let's unlock the problem. First of all, here's our problem. Lindsay's class is studying the solar system. 7 students are making models of the solar system. Each model has 9 spheres, 8 for the planets, and don't leave out Pluto, that little dwarf planet. How many spheres do the 7 students need for all the models? We need to find 7 times 9. One way that we can solve this problem is to use that distributive property that we have talked about so much. We have got this down. The distributive property using both multiplication and addition. So we can look at 7 times 9. We can break apart the 9 into the add-ins of 3 and 6. So we think that 9 equals 3 plus 6. We've got that. Then we take and multiply the 7 times the 3 and the 7 times the 6, and we add those two products together. What is 7 times 3, everybody? Good, 21. What is 7 times 6, everybody? Good, 42. You've learned your 6s, you've learned your 7s. I'm so proud of you. So now, what is 21 plus 42? Good, 63. So 7 times 9 equals 63. That's an easy way to solve it. We can use that distributive property. Now let's try another one. We are still going to use the distributive property, but we're going to mix it up just a little bit. Here we have 7 times 9 again. 7 times 9 equals 7 times, instead of the sum of two numbers, 9 is going to be represented by the difference of two numbers, 10 minus 1. 9 equals 10 minus 1, so this should still work. So we still have 7 times 9 equals, and we're taking this factor of 7 times each of these numbers. So 7 times 10, but now we're subtracting these two products. We are not adding them, we're subtracting them. Minus 7 times 1. Because what we're really doing here, boys and girls, we're taking an array of 7 rows of 9, and we're making it into 7 rows of 10, because that's easy, we know our 10s. Then we're going to subtract 7 rows of 1. We're just going to pull that 7 rows of 1 out so that we just have 7 rows of 9 left. So 7 times 10 is what, everybody? 70. You're so smart. This is tough. Think really hard. What is 7 times 1? I heard you. 7. Good job. And now, because we used a difference, we have to subtract. 70 minus 7 equals 63. Good job. So, students need 63 spheres for all of the models. You guys rock. All right, so now let's look at another way that we can solve the same problem. Here it is. Lindsay's class, solar system. We have 7 students making models. Each model has the 9 spheres. There's 8 for each planet, 1 for the little Pluto. So we still need to find 7 times 9. Let's look at another way that we can find 7 times 9. We can use patterns of 9. We did patterns with 2s and 5s and 10s and some of the other factors. So why can't we use patterns of 9? We can, and that's what we're going to look at. Here are some of the 9's facts. We have 1 times 9 equals 9, 2 times 9 equals 18, 3 times 9 equals 27, 4 times 9 is 36, 5 times 9 is 45, 6 times 9 is 54. So let's just look back at 1 through 6. What do you notice about the tens digit in each of these products? 2 times 9 is a 1 and an 8. 3 times 9 is a 2 and a 7. 4 times 9 is a 3 and a 6. 5 times 9 is a 4 and a 5. 6 times 9 is a 5 and a 4. So what do you notice about that tens digit? The tens digit is 1 less than the factor that is multiplied to 9. So we have 2 times 9, the tens digit is a 1. 3 times 9, the tens digit is a 2. 4 times 9, the tens digit is a 3. Do you see that as we keep going? Aha, some of you are going, oh wow, that's cool. Yes, there's patterns everywhere in life. So the tens digit is just 1 less than the factor that you're multiplying with 9. Now, what do you notice about the sum of the two digits together? 9 and 0, 1 and 8, 2 plus 7, 3 and 6. Are you catching on? 4 and 5, 5 and 4. I think you're catching it. The sum of the digits in the product is always what? 9. So, to multiply 7 times 9, we can think that the tens digit is 1 less than the factor that's multiplied by 9. So 7 is the factor. 1 less would be 6. And so we know that the 6, I'll put the 6 over here in the tens place. If it keeps with the same pattern, the ones digit should add together with the 6 to make 9. What number added to 6 makes 9? That's right, 3. So the product of 7 times 9 equals 63. All right, just for a bonus, let's see if we can do the next two. 8 times 9. What is the tens digit in this product? Whoa, you hardly let me get the question out. I heard you say a 7. Good. And then we know that these two numbers added together will equal 9. What digit goes in the ones place that added to 7 makes a 9? Awesome, a 2. So 8 times 9 equals 72. One more. You tell me, 9 times 9, what is 9 times 9 based on the pattern that we have just been looking at? Good job. The tens digit is an 8 because it's 1 less than 9. 8 plus 1 equals 9, so 9 times 9 equals 81. Wow, look at that pattern. That was really cool and easy. All right, let's do just a couple more and then we're going to be finished. Look at this. What is the tens digit in the product of 3 times 9? Think, what number is 1 less than 3? 2. So 2 is the tens digit. What is the ones digit? 7, because we know that 2 plus this number have to equal 9. So 2 plus 7 is 9. 3 times 9 equals 27. What about this one down here? 6 times 9. What's the tens digit? 5. It's 1 less than the 6. Good. Now we're looking for the ones digit, which would be 4, because 5 plus 4 is 9. Look how quick the 9s are. Oh, this is a toughie. 9 times 1, everybody? 9. So look at it. Does it still apply? does the pattern still work? It sure does. What's 1 less than 1? 0. What digit's in the tens place? 0. Do the two numbers add together to make 9? 0 plus 9 is 9. Sure does. It still works. All right, boys and girls, this has been your lesson for today. And now I want you to go on and do your blog and journal for this lesson. All right, I'll see you tomorrow. Bye.